We're taking a look at measurement and tuning of an ANC headset using the ZUMI Systems ANC production tool. The product that we have is an AMS based earphone set up in feedback configuration. So there's a little microphone inside, AMS chip on the board. We're communicating to the chip through an I2C line, so we have a bus on header on the back of the instrument that can run our I2C lines. We also have the option to run I2C through the line, and this board doesn't support that. So we're set up to adjust the gain until we hit a target. In this case I've set it to 10 dB. It's not a spectacular earphone, but it does demonstrate the functionality. So we get 9.3, 10.4 dB on this tune. It takes a couple of cycles, 9.4, 10.2. It takes a couple of cycles. In this case we're starting with the gain, with the microphone gain muted, is shut off. So our initial ANC curve is essentially a flat line. Then we compute a necessary gain adjustment and start to iterate that. It generally takes a couple of iterations, especially if the gain is muted, because you don't have any starting reference for okay, take about 2 cycles in this case for the 10 dB. So, okay, this product is comfortable at 10 dB. Kind of useless, but it does show the application. Just kind of, okay, that's fine. Now, in order to demonstrate that, we've got another gain setting. We'll put it at 16 dB. Again, these are all starting from a muted state, so the number of tuning cycles is unusually high. You wouldn't have this type of a setup in production. You'd set a best guess starting gain, which in a lot of cases would already be correct. Okay, now at 16 dB, we're setting the peak level very well, but our overshoot is too high, and that's quite a strong indicator of instability, so therefore we wouldn't accept that product if we exceed those limits, albeit the ANC curve does achieve the specified level. We'll take another look what else we've got there. Actually at 20 dB, basically it's going to be the same story as the 16 dB level. It's too high for this design, but we'll see what can be done in any event. And I'll just rescale the graph there. We can tune to 20 dB, but again, we can't accept that product. The overshoot level is too high. So all of these ones have been starting with a gain setting from the muted state and incrementing from there, which is an unusual thing to be doing. In this case, we'll go back to our 10 dB, and we'll start from a gain setting that's not quite high enough for 10 dB, but is not muted either. So our initial ANC curve will have some level. Here we go, 6 and 8. So it's basically one cycle to hit the target level when we actually have starting with a curve that is sensible. Excellent. That's just what we would expect to happen. I have another one here where I set the initial gain to a level that's much too high, and we'll see how that behaves. I don't know if the microphone can pick that up, but the earphone has gone unstable at the high gain setting, so there's the squealing noise coming out of it, and you can see the ANC curve becomes very messy as a result. But we're able to recover from an unstable state and still get the gain setting, our target gain setting,